In this video, we're going to talk about formula writing for ionic bonds. The biggest takeaway today is that the overall charge must be 0 for an ionic bond. So remember in the last video, we talked about how metals were giving away electrons and nonmetals were gaining electrons, all to do that to fulfill the octet rule. In this one, I'm going to show you how to figure out that formula without having to draw those Lewis dot diagrams every single time. And to do that, you have to be very familiar with the charges on the periodic table. So I'm going to bring over this periodic table. That is not the exact one that you will be using in my class, but it works. All right, so you need to remember that everything here has a common charge of +1 because everything here has one valence, and we'll lose that one valence to fulfill the octet rule. This one will have +2. This one will be +3. This one is plus or minus 4. Now, to be tested on this, you would be told whether or not it is plus or minus 4. There's some exceptions down here that we'll get to later. This one's -3 because it has 5 valence. It would gain 3 electrons. This would be -2, -1, and 0. This is one of those things that you got to have memorized. Find some funny way to remember these charges. +1, +2, +3, plus or minus 4, and then starts counting backwards in the negatives. That's how I remember it, but you find something that works for you. So in this, we're going to have the overall charge be 0. To start, we'll start with something like magnesium and oxygen. This is fairly easy. I shouldn't say easy. I mean, I know it's difficult because it's new. This is one of the easier problems that you will have. So you look here, you find magnesium. It has a +2 charge. You're going to put a +2. You find oxygen. Oxygen has a -2 charge. You want the lowest possible ratio for the overall charge to be 0 when you put these things together. Well, if I have 1 Mg, that's +2. 1 oxygen's -2. This -2. That's 0. So I only need 1 of each. My formula is MgO. That's it. I'm done. Now let's do something that's not going to be 1 and 1. Sodium and oxygen. Sodium is a +1. Oxygen is a -2. I'm moving a little fast with the charges. Just know I'm looking at the periodic table to figure it out. Now for this one, I have a +1 and a -2, so that's not overall 0 if I just have 1 of each. So I need another Na. If I have another Na, I have +1 and +1, that makes an overall +2, and a -2, that's going to cancel. Well, it took 2 Nas to do that, so I'm going to put a little 2 down here, and then 1 oxygen, so I just put an O. Now, what if I have a polyatomic? And I'm going to make this one a little bit more difficult because I think it's okay. I think we got this. Let's say that I have calcium and phosphate. This is why it's so important that you know your charges. So calcium, you look on the periodic table, it's +2. Phosphate is PO4. You do have to have it memorized, 3- or -3. I always switch how I write these. This one's more difficult because 2 and 3 don't go into each other. However, 2 and 3 both go into 6. So we want to have a +6 charge overall and a -6 charge overall. So to do that, I'm going to add another calcium. And now I'm at +4. 3 still does not go into +4. So I'm going to add another one. And now I have an overall +6. 3 does go into +6, but I need 2 of them to make that happen. Overall, +6 and -6 cancels to a 0 charge. It took 1, 2, 3 Ca, so I'm going to put a little 3 on bottom. And it took 2 PO4s. Now, when you write 2 PO4s, you cannot write it like this. Because if you write it like this, it looks like I have 42 oxygens. You have to take your PO4 and put it in parentheses. PO4 is a team. You never break it up. There's always 4 oxygens with 1 phosphorus. So you just put parentheses around the whole thing and then put however many you need on the outside. This means I have 2 of everything in here. So I have 2 phosphorus and 8 oxygen. And then I have 3 calciums over here. And that's my formula.